In this video, we're going to develop a strategy to factor a sum or a difference of two perfect cubes. In the last video, we ended by foiling this binomial by this trinomial. And we found that when we foiled, we got this expression. And we said that that particular expression was a sum of perfect cubes because x to the third is a perfect cube because it's x times x times x. Y to the third is a perfect cube because it's y times y times y. And of course, it's a sum because we're adding those two terms. And we decided that if we were to try to factor this x to the third plus y to the third, this sum of perfect cubes, that it should look like this FOIL. So how do we develop a pattern or develop a strategy for factoring a sum of perfect cubes? The first thing that we need to know is that whether we're trying to factor a sum of perfect cubes or a difference of perfect cubes, that type of expression will always factor into a binomial times a trinomial. Every time. There's nothing to think about. So anytime I see a sum or a difference of perfect cubes and I know I need to factor it, the first thing I do is make room for a binomial and make room for a trinomial. So now let's talk about how to get the two terms in the binomial factor. In this case, the x and the y. The first term in the binomial factor will always be the cube root of the first term in the sum or difference of cubes. So the first term here in the binomial is x because x is the cube root of x to the third. The second term in the binomial factor is found the same way. The second term here, a y, is the cube root of the second term in the sum or difference of cubes. The second term in the sum is y cubed. The cube root of that is y. So the second term in our binomial factor is a y. So really this binomial factor is made up of the cube roots of each of the terms in the original expression. Now let's talk about how to get the terms in the trinomial factor. The first term in the trinomial factor, in this case the x squared, will always be the square, not the square root, the square of the first term in the binomial factor. So in this case, take the x, the first term in the binomial factor, and square it to get the first term in the trinomial factor, x squared. To get the last term in the trinomial factor, in this case the y squared, square the last term in the binomial factor. So square the y to get y squared, and that will always be the third term in the trinomial factor. So quick recap. To get the first term in the trinomial factor, square the first term in the binomial factor. To get the last term in the trinomial factor, square the last term in the binomial factor. And last but not least, how do we get the middle term in the trinomial factor? Well, we just take the first and second terms from the binomial factor, in this case the x and the y, and multiply them together to get xy. And if we multiply both terms in the binomial factor together, we will always get the second term in the trinomial factor. So there's the pattern for factoring a sum of two perfect cubes. But how does that pattern compare when we're factoring a difference of two perfect cubes? Well, let's compare the two. Here, up at the top, we have x cubed plus y cubed. That's a sum of perfect cubes. And here we have x cubed minus y cubed. That's a difference of two perfect cubes. Let's compare the factorizations. Both of them factor into a binomial times a trinomial. The first term in the binomial factor for each of them is the cube root of the x cubed. The second term in the binomial factor is y, which is the cube root of the y cubed. The first term in the trinomial factor is x squared, which is the square of the first term in the binomial factor. The middle term in both of the trinomial factors is xy, and the last term in each of the trinomial factors is y squared. The only thing that's different between the factorization of a sum of two cubes and the difference of two cubes are the signs between the terms in each factor. plus here, minus there, minus here, plus there. The two last ones are the same, however. So if you can remember the pattern for factoring a sum of cubes, you can remember the pattern for factoring a difference of cubes. The only thing that's different is the signs between the terms. So how do I remember the signs, or how do we remember the signs? We can use the acronym SOAP to help us. The S in the acronym SOAP stands for same. So if I'm factoring a sum of two cubes, then my first sign that I come across has to be the same as the one I started with. If I'm factoring a difference of two cubes, the sign between the two terms in the binomial factor has to be the same. So S means same. O stands for opposite. The next sign that I see in my factorization, the sign between the first and second terms in the trinomial factor, has to be the opposite of the one that I just entered in the binomial factor. And then A and P stands for always positive. The last sign, or the sign between the second and third terms in the trinomial factor, is always positive. No matter if I'm factoring a sum of cubes or a difference of cubes, that sign is always positive. Now that we've identified a strategy for factoring the sum of two cubes and the difference of two cubes, in the next video, we'll do some examples.